Welcome to day 99 of my coding. This time we are in data science. We're going to analyze the data from the nextspaceflight.com. First, guys, we have to clean up our data. So after we clean up our data, first is the number of launches per company. So we use the value counts. We use the Plotly Express bar, and this is the output, guys. So USSR is number one as to the number of launches per organization, seconded by Arianespace, and NASA is ranked number 5. This time we're going to trace the number of active versus retired rockets. We have 3,534 retired rockets and 789 active rockets. So the distribution of mission status, we used again value counts. During their mission, 89.71% of the rockets were successful in their mission, and 7.84% of them failed. The question is, how expensive are the launches? So we have to clean the data first. Out of the 4,000 plus data, after cleaning it up, 957 rows remains after we cleaned up our data. So we plot it using the Seaborn to check the kernel density estimate, or the distribution of the price in our data. By average is 153.76 million per launch. The next question is a map to show the number of launches per country. This is the results of the number of launches per country. Okay, guys, so USA has 1,351 total launched rockets, and Russia has 1,434. And actually, guys, we have to include also Kazakhstan as part of the USSR. China has 268. By the way, we use the PX, that choropleth. Now we're going to show the number of failures by country. So this is the result, guys. We use the same technique. Again, guys, using Plotly Express Sunburst. So we are going to chart the country's organization and mission status. After we use the techniques such as group by and aggregate, so the result is this, guys. It's beautiful. Actually, I like this sunburst. So if we click this, it expands, and you can zoom in and you can zoom out. So beautiful. Yes. So ULA and NASA, General Dynamics, SpaceX, Boeing. Yes. And we have Kazakhstan. Actually, until 1991, they belong to the USSR. So, okay, so our data looks beautiful with this. China. Okay. And we have also France, Arianespace, okay, with several organizations. Okay, so that's for Sunburst, and we analyze the total amount of money spent by organization on space missions. We use the aggregate price. So that's our technique, and the result, guys, is this. And if we chart the number of launch per year, this will be the result, guys. From 1960 until 1980, there was kind of a space race era. I think this is Matplotlib bar, okay, and while this one is, we're using Plotly Express bar. Okay, for example, this one, 1971, number of launches during that year is 116. So this time we're going to chart the number of launches month on month until the present. And the result, guys, is this. So since 1957 until 2020, and we use the rolling amount. So we got a rolling average of 6 months. Okay, so to show the average, the red one is if we can zoom in. Actually, we can zoom in, guys. So the red represents the red bar represents the actual number of launch per month, which months are the most popular and least popular for launches. So we just use the name of the month or the number of the month, and we exclude the number of the year. So the result, guys, is that the most popular launching month is the month of December. The question is, how has the launch price varied over time? So the launch price has kind of decreased over time compared to the earlier era. I think the rockets became more efficient. Okay, and the cost of launching actually substantially decreased. This is the same data, but we just presented it in different techniques. We're using here Matplotlib for this one, and Plotly Express for this one, and SNS Seaborn for this one. We chart the number of launches over time by the top 10 organizations. Originally, we did the top 10 organizations, but somehow my favorite one, SpaceX, did not make it to the top 10. So we revised the selection to top 11, and somehow SpaceX made it to top 11. But I think if our data is until 2023 or 2024, probably SpaceX will make it to, maybe SpaceX will go at the higher rank. And we plot our data, and this is the result. And then let's check, guys, the Cold War space race. USA versus USSR. We added Kazakhstan to the USSR. We plot the data using the Plotly Express Pi, and the result, guys, is that USA had 27.4% of the number of launches, total of 644 launches, while USSR is 1,709. A 72.6%. And we create a chart, guys, to show the total number of launches year on year by the two superpowers. So the result, guys, is this. Okay, the data from 1957 until this. The data is until 1991. Okay, until the end of Cold War. And so we plotted it, guys, using Matplotlib, and this is the result, guys. So Russia had more launches, number of launches, and we chart the percentage of failures over time, and the result, guys, we converted it to percentage, and this is the result. Somehow the percent of mission failure went down from the beginning of the space race era. There were roughly around close to 75% failure, but by 2020 it's just down to 10% or less. So for every year, show which country was in the lead in terms of total number of launches up to the and including 2020. So based on our calculation, guys, using technique group by and aggregate of the launching count. Okay, the result, guys, is if we chart it and we pivot the table, so this is the result, guys, per organization from 1957 until 2020. And we used another technique called Plotly Express that line, and this is the result. Okay, guys, it's more interactive. I like it. Thank you, guys. That's it for day 99.